So I'll be talking about dam breach. This project, it's part of an ongoing series of PhDs. Basically, it started with the Pluff project, where Priska Hiller did her PhD on basically riprap and on rockfill dams. And then continued with Ganesh, whom many of you know, finished last autumn. And then I've been picking up and trying to continue the work done by Ganesh. So this is where it started with Priska's model in the lab. Basically looking at riprap of a dam, downstream slope of a dam, including the underlying filter layer. And this thing breached at around 300 liters per second. But then they started thinking, oh, but okay, the toe here is fixed. There was a steel plate at the end. So Ganesh wanted to look into this, and then he had the end loose. And then suddenly it breached at 60 liters per second. And then, yeah, basically the conclusion is, oh, the toe is important. And then also he started looking into, there is also some through flow. There is water flowing through the supporting fill in the rockfill dam, and it comes out from the dam. That helps destabilize the rocks. Wonder what that has to say. Oh, 30 liters per second. And then we continue. And then I have started building even a bigger dam. Ganesh had built half a dam. Now we're building a whole dam. And we're also including not a metal core as Ganesh did, but a flexible one, so that we can see a bit more of the evolution of the breach. So the first tests we did was this model with 4.5 tons of downscaled rockfill material, basically. We build it in layers and compact it as one would with a proper rockfill dam. And then now this last spring semester, we've been adding the filter and the riprap as well. So now we're past 5.5 tons of material in the model, and all this material basically has to be shoveled twice for each test, back and forth. It's a bit of work. So I joke that my students don't have any trouble with the corona closed gyms, because they get plenty of exercise anyway. This is where we're doing it, the large flume in the hydraulics lab, where we've set up on a raised platform, basically. And we've set up with cameras all around, and we've got this tent on the outside of the flume to keep stray light out. And we're measuring all sorts of stuff here. The model is basically like this. It's 1 meter high dam without the riprap, and then we're adding almost 20 centimeters with the riprap, since it's the 100 millimeters filter layer, and then the riprap rocks there between 80, 90, 95 millimeters. We're also measuring the pressure in the base. So this is our full dam. Now let's see if we can get the video running. Yes. So this is the dam without the riprap. And of course, what happens is that without the riprap, it starts eroding as soon as you overtop the dam. And the whole supporting fill is basically saturated with water and quite unstable. So we're getting this gradual erosion of the dam, and it's digging down quite quickly, and it's digging down fast, but sideways it's eroding somewhat slower. And the side slopes, they are pretty much vertical. I could mention that in dam bridge calculations, often people use a one-to-one slope or something like that, which is not particularly realistic, as we can see from these tests at least. See, so this is what we get. We are doing quite a lot of image analysis. We're building 3D models of this dam before and after the breach has happened, based on photos taken with a single lens camera. But then we're also taking a lot of video. And with the video, we are basically creating a dynamic 3D model. So with whatever time step we choose, in this case, it's just an early test, so I used 30-second time steps. But we could basically go all the way down to the 50 frames per second of the video. Of course, that would take weeks or months to process, so that's not really particularly realistic. But it's a way to track the development of the breach. We're also doing some other types of image processing, PIV, particle image velocimetry. In this case, without using tracers or anything like that. Our tracers is basically the rocks. And we're going to look more into how the rocks move during the breach. This was also done on some of the tests Ganesh did. And we're trying to continue doing similar work. So, and this is actual speed. So when you have the riprap on the dam, the breach happens very, very fast. And that's one of the things we're looking into. What does this actually mean for our dams? We're making them a lot safer by adding the riprap on top of the dam. But if the dam breaches, it happens a lot more violently in a way. In an unprotected dam, basically it erodes gradually. Whereas the riprap protection, it overtops a lot more before it finally breaches. And when it breaches, it happens a lot more quickly. So that's also something we're interested to look further into. Here we can see the breach from above as well. And again, it's not sped up or anything. It's at its full speed. There it goes. And then you can see the riprap rocks are flying away quickly. Also, we're measuring pressure along the base of the dam to see, yeah, we've been looking at that earlier in seeing how pore pressures develop depending on different construction, what kind of drainage you have in the toe and so on. But we've kept that to also see a bit more on what happens during the breaching, because in the upstream part, you'll see a gradual reduction in the pressure, but in the downstream, you'll get an increase in the pore pressure as the whole thing slides down. here are some of the publications that have come out of this series of works. I've been fortunate enough to participate in one together with Ganesh, where we looked at through flow. And that is basically everything I have, and I've already exceeded my time with 1 minute. Thank you.